Hello, chat. Doing. We're kicking butts, taking names, holding it down. Hello, Jimothy. You being good today? Hi. Hi. I have added a thingy-mabob, which is cool. Hey, Johnny! It's good to see you, bud. I added a thingy thing, if that makes sense. I mean, you will see it when... Actually, I realize you'll probably see it as soon as I switch scenes. um... I've been talking about it for the last, like, week or so, and I finally did it today. Look. Oh, yeah. I got the little controller map. I might change its placing, but like that's what we got so far. Now I can find out how stupid I am when we do the things. Um have you guys been getting like thrown like every single like live on YouTube recently? Because I have.
Or rather,
I always try hard, my friend. But yeah, look. See? You see how it moves? I'm like the ones on the backs don't actually show that much. That's so funny. Oh yeah, this is where Johnny, this is where you're gonna find out that I have changed my R1 and R2s for Elden Ring and every other Soulsborne game. Otherwise you'll think I'm like constantly pushing R2 all the time. Which like I mean I guess I am because of the trigger. I'm just more comfortable using the triggers for like light attacks. Oh lord. Yeah, so the story behind that is when I was playing Sekiro for the first time. I broke the bumpers. I broke the not both of them, but I broke the left bumper while parrying all the time, right? And so I didn't have enough money or time to go and get um another controller. So I just remapped it and learned how to use the left trigger for like parrying and everything. So yeah. That's what I do now. Hey Olivia. How's your day going? Oh Jesus. No, I don't want any work. Goodbye. Jesus Christ. Bro, Kicker's nothing but bots. What the fuck? Um, so yeah. To compensate when I broke the left bumper, I changed both over because it was too weird doing like one and not the other. And now I'm just way too used to it. I actually think it's better. I've never gone back. I think the triggers are like way better for like light attacks and everything. And if I want to do heavy attacks, I just hold down the right bumper instead. What are we looking for? Weird. I don't know why that was so weird, but oh well, whatever. I had a problem with like my streamer bot connecting to the YouTube shit. It's fine now. I don't know what the problem was previously. But we're gonna do some code learning and then we're gonna head into what do you call it? the DJ Max portal. No, I'm just joking. Then we'll head into you know, Elden Ring. Fuck, my brain would not come up with the word.
How can we actually use recursion constructively? Well,
Oh, yeah, we got to change the game type. Jim, if you're there, could you change it for me, my friend?
let me propose
Software and game development.
that we actually introduce a third and final algorithm for sorting that hopefully does better than the two sorts thus far. We've done selection sort and bubble sort. Bubble sort
Oh, yeah.
we liked a little better, at least insofar as in the best case where the list is already sorted. Bubble sort's at least smarter, and it will actually terminate early, giving us a better lower bound in terms of our omega notation. But it turns out that recursion, and this is not necessarily a feature of recursion, but something we can now leverage. It turns out using recursion, we can take a fundamentally different.
What did you come into? So I've been doing this thing, Sack, where we look at learning some code together because I want to learn code and chat can learn with me. Eventually, it's gonna be me making some stuff too on stream, but at the moment I'm just learning. So you know, we're halfway there. Not literally, like halfway is like over here, but you get the idea. I hope you've been doing well, Sack. Also, look up. My hand's getting cut off. Look over there. I got a little like wiggly woo. I assume that's big enough for you guys to like see. If I need to make it bigger, I suppose I can.
Approach to sorting a whole bunch of numbers in such a way that we can do far fewer comparisons and ideally speed up our final results. So here is the pseudocode for what we're about to see for something called merge sort. And it really is this terse. Sort the left half of numbers. Sort the right half of numbers. Merge the sorted halves. Right? This is almost sort of nonsensical because if you're asked for an algorithm to sort and you respond with, well, sort the left half, sort the right half. Like that's being sort of difficult because, well, I'm asking for a sorting algorithm. You're just telling me to sort the left half and the right half. But implicit in that last line, merging, is a pretty powerful feature of this sort. Now, we do need another base case at the top. So let me add this. If we find ourselves with a list, an array of size 1, well, that array is obviously sorted. If there's only one element in it, there's no work to be done. So that's going to be our base case, but allowing us now in just these, 6 lines of pseudocode to actually sort some elements. But let's focus first on just a subset of this. Let's consider for a moment what it means to merge sorted halves. So Carter has wonderfully come up to volunteer here just to help us reset these numbers. Suppose that in the middle of the story we're about to tell, we have two sorted halves. I've already sorted the left half of these numbers, and indeed 2, 4, 5, 7 is sorted from smallest to largest. And the right half appears to be already sorted. 0, 1, 3, 6, already sorted. So in my pseudocode, we're already done sorting the left half and the right half somehow, but we'll see how in a moment. Well, how do I go about merging these two halves? Well, because they're sorted already, and you want to merge them in order, I think we can flip down. We can hide all but the first numbers in each of these sublists. So here we have a half that starts with 2. And I don't really care what the other numbers are because they're clearly larger than 2. I can focus only on 2. And 0, 2. 0 also. We know that 0 is the smallest there. So let's just ignore the numbers that Carter kindly flipped down. So how do I merge these two lists into a new sorted larger list? Well, I compare the 2 on my left with the 0 on my right. Obviously, which comes first? The 0. So let me put this down here. And Carter, if you want to give us the next element. Now I have two sorted halves, but I've already plucked 1 off. So now I compare the 2 against the 1. 1 obviously comes next. So I'm going to take out the 1 and put it in place here. Now I'm going to compare the two halves again. 2 and 3, which do I merge first? Obviously, the 2 comes next. And now notice, each time I do this, my hands are theoretically making forward progress. I'm not doubling back like I kept doing with selection sort or bubble sort, back and forth, back and forth. My fingers are constantly advancing forward, and that's going to be a key detail. So I compare 4 and 3. 3, obviously. I compare 4 and 6, 4 obviously. I compare 5 and 6, 5 obviously. And then I compare 7 and 6, 6 of course. And then lastly, we have just one element left. And even though I'm kind of moving awkwardly as a human, my hands technically were only moving to the right. I was never looping back, doing something again and again. And that's perhaps the intuition and just enough room for the 7. So that then is how you would merge two sorted halves. We started with left half sorted, right half sorted. And merging is just like what you would do as a human. And Carter just flipped the numbers down. So our focus was only on the smallest elements in each. Any questions before we forge ahead with what it means then to be merged in this way?
Merge.
So now, here is an original list. We deliberately put it at the top because there's one detail of merge sort that's key. Merge sort is technically going to use a little more space. And so whereas previously we just kept moving our humans around and swapping people and making sure they stayed ultimately in the original positions, with merge sort pretends that here's our original array of memory. I'm going to need at least one other array of memory. And I'm going to cheat, and I'm going to use even more memory. But technically, I could actually go back and forth between one array and a secondary array.
Ice cream.
But it is going to take me more space. So how do I go about implementing merge sort on this code? Well, let's consider this. Here's an array of size 8. If only one number quit, obviously not applicable. So let's focus on the juicy part there. Sort the left half of the numbers. All right, how do I sort the left half of the numbers? I'm going to just nudge them over just to be clear which is the left half. Here is now a sub list of size 4. How do I sort the left half? Well, do I have an algorithm for sorting? Yeah, what do I do? Here's a list of size 4. How do I sort it? What's step 1? Sort the left half. So I now sort of conceptually in my mind take this sublist of size 4, and I sort it by first sorting the left half, focusing now on the 7 and 2. All right, here's a list of size 2. How do I sort a list of size 2? Sorry? I think we just keep following our instructions. Sort the left half. All right, here is a list of size 1. How do I sort a list of size 1? I'm done. Like, it's done. So I leave this alone. What was the next step in the story? I've just sorted the left half of the left half of the left half. What comes next? I sort the right half of the left half of the left half. And I'm done, because it's just a list of size 1. What comes after this? Merge. So this is where it gets a little trippy, because you have to remember where we're pausing the story to do things recursively again and again. But if I've just sorted the left half and I've just sorted the right half, now I merge them together. This is a super short list, so we don't need Carter's help here as before. But I think the first number I take here is the 2. And then the second number I take, because it's the only option, is the 7. But what's nice now is that notice the left half of the left half is indeed sorted, because I trivially sorted the left half of it and the right half of it, but then merging is really where the magic happens. All right, again, if you rewind now in your mind, if I've just sorted the left half of the left half, what happens next? Sort the right half of the left half.
Yep.
So again, you kind of rewind in time. So how do I do this? I've got a list of size 2. I sort the left half, just the 5, done. Sort the right half, 4, done. Now the interesting part, I merge the left half and the right half of the right half of the left half. So what do? 4 comes down here, 5 comes down here.
Hello, hello. Hello, you know. I have ice cream.
And now, notice what I have. Left half is sorted, right half is sorted. If you rewind in time, where is my next step? 3? Merge the two halves. And so this is what Carter helped me do before. Let's focus only on the smallest elements just so there's less distraction. I compare the 2 and the 4. 2 comes first, so let's obviously put that here. Now I compare the new beginning of this list and the old beginning of this list. 4 obviously comes next. And now I compare the 7 against the 5. 5 obviously comes next. And now lastly, I'm left with one number. So now I'm down to the 7. So even if you've kind of lost track of some of the nuances here, if you just kind of take a step back, we
Learning? Nice. What flavor? So the drumstick. So it's vanilla and then chocolate outside. And then cone. And then it had nuts on top.
have the original right half here still untouched, but the left half of the original input is now indeed sorted. All by way of doing sorting left half, right half, but with those merges in between. All right, so if we've just sorted the left half, we rewind all the way to the beginning. What do I now do? All right, so sort the right half. So sort the right half. How do I sort a list of size 4? Well, I first sort the left half, the 1 and the 6. How do I sort a list of size 2? You sort the left half. Just the number 1. Obviously, there's no work to be done. Done. Sorting the left half. 6. Done. Sorting the right half. Now, what do? I merge the left half here with the right half here. And that one's pretty straightforward. Now what do? I've just merged. So now I've just sorted the left half of the right half. So now I sort the right half of the right half. So I consider the 0, done. I consider the 3, done. I now merge these two together. 0, of course, comes first. Then comes the 3. And now I'm at the point of the story where I've sorted the left half of the right half and the right half of the right half. So step 3 is merge. And I'll do it again like we did with Carter. All right, 1 and 0. Obviously, the 0 comes first. Now compare the 1 and the 3. Obviously, the 1
no worries.
comes first.
Be good, bud.
Compare the 6 and the 3. Obviously, the 3. And then lastly, the 6th. So now where are we? We've taken the left half of the whole thing and sorted it. We then took the right half of the whole thing and sorted it. So now we're at lastly, step 3 for the last time. What do? Merge. And so just to be consistent, let me push these down. And let's compare left hand to right hand, noticing that they only make forward progress, none of this back and forth comparisons. 2 and 0, of course, the 0. So we'll put that in place. 2 and 1, of course, the 1. So we put that in place. 2 and 3, we merge in, of course, the 2 in this case. 4 and 3, we now merge in the 3 in this case. 4 and 6, we now merge, of course, the 4 in place. And now we compare 5 and 6. We keep the 5. Bug. OK, well, pretend that the 5 is on. Oh, this is why. All right, so now we compare the 7 and the 6. 6th is gone. And lastly, 7 is the last one in place. And even though I grant that of all the algorithms, this is probably the hardest one to stay on top of, especially when I'm doing it as a voiceover, realize that what we've just done is only those 3 steps recursively. We started with a list of size 8. We sorted the left half. We sorted the right half. And then we merged the two together. But if you go down each of those rabbit holes, so to speak, sorting the left half involves sorting the left half of the left half and the right half of the left half, and so forth. But this germ of an idea of really dividing and conquering the problem, not such that you're having the problem and only dealing with one half. Clearly, we're sorting one half and the other half and merging them together ultimately. It does still lead us to the same solution. And if we visualize the remnants of this now, if I depict this as follows, where on the screen here, you see where the numbers originally started in the top row from left to right. Essentially, even though this is in a different order, I divided that list of size 8 ultimately into 8 lists of size 1. And that's where the base case kicked in and just said, OK, we're done sorting that. And after that, logically, I merged 2 lists of size 1 into many lists of size 2. And those lists of size 2 into lists of size 4. And finally, the lists of size 4 into one big list sorted of size 8. And so I put forth this picture with the little line indicators here because how many times did I divide in half? Or really double, double, double. So exponent is the opposite. Oh, spoiler. How many times did I divide? So 3 concretely. But if there's 8 elements total and there's n more generally, it really is a matter of dividing and conquering log n times. You start this, and you can divide 1, 2, 3 times, log n times. Or conversely, you can start here and exponentially double, double, double 3 times, which is log n. But on every row, every shelf, literally, I made a fuss about pointing my hands only from the left to the right, constantly advancing them, such that every time I did those merges, I touched every element once and only once. There was none of this back and forth on stage. So if I'm doing something log n times, or if I'm doing rather n things log n times, what would be our big O formula perhaps? N things log n times? Yeah, so n log n, the order of n log n is indeed how we would describe the running time of merge sort. And so of all of the sorts thus far, we've seen that merge sort here actually is n log n, which is strictly better than n squared, which is where both selection sort and bubble sort landed, but it's also slower than linear search, for instance, but you would rather expect that. If you have to do a lot of work up front sorting some elements versus just searching them, you're going to have to put in more effort. And so the question of whether or not you should just search something blindly with linear search and not bother sorting it really boils down to, can you afford to spend this amount of time? And if you're the Googles of the world, odds are you don't want to be searching their database linearly every time. Why? Because you can sort it once and then benefit millions, billions of people subsequently using something like binary search, or frankly, in practice, something even fancier and faster than binary search. But there's always going to be this trade-off. You can achieve binary search only if the elements are sorted. How much does it cost you to sort them? Well, maybe n squared if you use some of the earlier algorithms, but it turns out n log n is pretty fast as well. So at the end of the day, these running times involve trade-offs. And indeed, in merge sort 2, I should note that the lower bound on merge sort is also going to be omega of n log n. As such, we can describe it in terms of our theta notation, saying that merge sort is indeed in theta of n log n. So generally speaking, probably better to use something like merge sort or some other algorithm that's in n log n. In practice, most programmers are not implementing these sorting algorithms themselves. Odds are they're using a library off the shelf that themselves have made the decision as to which of these algorithms to do. But generally speaking, and we're seeing now this for the first time, if you want to improve time, like use less time, write faster code, you've got to pay a price. And that might be your human time. Just takes you more time to code up something more sophisticated, more difficult to implement, or you need to spend something like space. And as these shelves suggest, that too is one of the key details of merge sort. You can't just have the elements swapping in place. You need at least an auxiliary array so that when you do the merging, you have a place to put them. And this is excessive, this amount of memory. I could have just gone back and forth between top shelf and bottom shelf, but it's a little more interesting to go top down. But you do need more space. Back in the day, decades ago, space was really expensive. And so you know what? It might have been better to not use merge sort, use bubble sort or selection sort even, or some other algorithm altogether. Nowadays, space is relatively cheap, and so these are more acceptable trade-offs. But it totally depends on the application. The very last thing we thought we'd do is show you an actual comparison of some of these sorting algorithms. It's about 60 seconds long, and it will compare for you.
This isn't dressed to impress.
Sort, bubble sort.
Wait. What do you mean? Oh, wait, you mean because of the game. Right. Look. Hey. I will play it as soon as I beat Radahn, okay? Also, imagine enabling Twitch drops. I haven't done shit. Okay? I haven't done shit. I've had... Guess we'll never play... This... Undistinguished woman. How dare you? Rude. I'll have you know that I'm gonna beat his ass today, okay? It's gonna happen, and it's probably gonna happen, like, really quick in the stream, to be honest. I'm really close to beating this shit. Also, funnily enough, I was doing better when I was talking to you guys than I was when I was by myself. It was very annoying. Zero faith in you beating Gandalf before I'm bored of Dress to Impress. What, are you bored of it already? Rude. Also, Kate is a big fan of the EP emote. I showed her it today, and I told her you made her a Caucasian. She was, very amused. I need white noise? Whoa. Rude! Just because I am partially white doesn't mean that me talking is just white noise. That is rude, Peg. I do really like that emote. I think it's sick. I'm half tempted to get like an animated version of it. It's so good. Ugh, I just closed my coffee on myself. How you doing today, Peg? Ugh. Oh, stretch. Yo, Gucci? Oh, alright. I can accept that. Um, I heard that I'm really disappointed because I wasn't trying to find out the end of My Hero, but being on Twitter made me spoiled for it. I didn't even know it was near the end, and apparently it's at the end. And so I get an idea of what happened, and I'm sad. Well, I mean, the ending for him, I don't get like the actual like, but before that, I just know, yeah, a part, and that I'm not really like. Also disappointed, refused to watch past season 2. You could take the time to animate one and actually do more than 2 frames. Oh, hell yeah, Paige. Wait, what is this like do more than 2 frames shit that like what are you trying to say? Huh? What do you mean? Explain yourself. I like the one I made before. I hated that Ibis doesn't allow transparent animation. You've made it? You've done an EP one before? What one was that? I'm sure there's wait, if you've done one, I'm sure there's probably something you can do to like make it can go somewhere to make it transparent. The animated EP emote I did was lazy and only 2 frames. Oh, okay, got it. Got it, got it, got it, got it, got it. I thought you were like having a dig at like my stubborn emote, and I was like, that's more than 2 frames, thank you very much. When you tried, there was a green edge around it. That's rough. That is rough. I mean, if you do like a animated emote for it, that would be great. I'd really appreciate it. I think it would be sick animated. That was a very itchy nose, huh? If you do an animated one, it would have to be full square. Sure. You can have the full square if you want the full square. Wait, wouldn't it be funny if Kate's face plants into the disc? That would be amazing, yes. It's like the opposite of my one. It would be the partner to yeah. It definitely would be the opposite to my stubborn emote. Yes. I had the same thought. That would be a great emote. Whew. Ugh. I've been thinking about changing my camera thing here too. I'm just not sure what I would change it to. You're inspired now? Hell yeah. That would be cool. Joshy boy not just playing Outer. No, no, no. But I've been fairly regular with this recently, Loco. It just happened to be the times that you were stopping by, I wasn't doing it. But you've come by now. Hello! How you doing, Loco? Hope you're having a good day, bud. Oh, it is warm in here. I just finished having ice cream as well.
And merge sort in parallel, simultaneously, with some fun sorting music, showing you ultimately what it really means to be an O of n squared, or better yet, big O of n log n. Selection on the top, bubble on the bottom, merge in the middle.
Got a Muller pulled, Mauler pulled, so I'm on just room temp soup and no drinking or smoking diet. Ooh. Well, I mean, I don't really have a problem with the drinking or the smoking, but the only soup thing would be rough. Sorting algorithms? Yes, Jim. Yes, this is important.
All right, that's it for CS50. We'll see you next time.
How yeah, definitely, Jim. Memories. How's the studying for you been going anyway, Loco? I hope it's been going well, my friend. How are you doing, Jim? Peg has been inspired to make a new animated emote for chat. I'm pretty excited. I can't tell if you like that emote or not, Peg. You really like it? Okay, I was gonna say, because, like, I've seen a few people use it, including Shady, and they seem to really like Perry a lot. I think that might be the best one you've done so far, Jim.
Right, this is CS50, and this is week 4. And if you think back a few weeks ago already, in week 0, we started talking about, like, what images are.
The Perry emote is fire. Thank you, Peg. I worked very hard. I think it's great too, Loco. Oof. This one terrifies me. That's pretty funny. Good. Well, I mean, Jim does have a few, like, slots taking up on my amount of, like, emotes that I have. He's probably, at this point, made more emotes for me than I have for myself. It's this shitty Roblox face with real eyes. I hate it. It's pretty funny. I told Lollies to take a hike. Lollies is busy with his life, my friend. Also, time zones kind of, like, suck for me to, like, get him to do anything. Figures? Oh, he's a good lad, man. He'd do whatever I ask. If I wanted some more stuff, I suppose. But I haven't really thought of anything. I mean, the EP stuff is great. I like the stuff you guys have been giving me. There's no way my art would still be here if he wasn't. His art is cool as fuck. His art is sick, yeah. I wish we could do, like I was saying before, I wish we could just straight up have gigantic emotes in chat that people could use rather than like, I mean, it's cool gigantifying some stuff, but like I wish we could just have like gigantic emotes. I don't know, like it'd be locked behind like tier 2 or some shit. Like then people would actually buy tier 2 like things or like tier 3. You need to redraw the scream emote? Who made this? Paige did, bud. Isn't it cool? I uploaded it yesterday, but not everyone could see it. Peg wants to do an animated version of it, buddy. I think it's such a cool idea. If you want to redraw the scream, Peg, you're more than welcome to. I still feel like I need a new like a emote. Like the Rue H emote that you have. I feel like I still need one like that.
We talked about representation of.
You didn't even know it was yours until just now. Fair. Yeah, that one. Ram Pi to Ra.
Images is this grid of pixels, and each pixel has like some pattern of bits that defines its color. Well, it turns out today we'll take a deeper look underneath the hood at how things like images and so much more is actually implemented using just these zeros and ones, and how now, as a programmer, you can actually harness that, for better or for worse, to
Yours isn't even good.
And
it's pretty good. I like it. It's too hazy. If I like the eyes in it, it's just like it's too bright on like a light color. That's all. If it was like a little bit darker, then it would probably be fine.
Better manipulate what's going on inside of a computer's memory using a language like C. In fact, even this bowl of stress balls that we keep happening is just a photograph, of course, but if you think back to week 0, if you sort of enhance this image, like they do in the movies, it actually doesn't work out the way you would think from Hollywood. As I continue to zoom in and zoom in and zoom in on a screen like this, you'll see that, yes, it gets bigger, but if it gets too big, what do you start to notice? The so-called pixelation, and indeed you can see the individual dots. So next time you watch some show or movie on TV that has this sort of notion of enhancing, you know, there's actually a finite limit there. You can only enhance so far as there's actually information there. But once you zoom into a certain level like this, like that's all that's there. You're not going to see the glint of the suspect in some crime.
That's what my problem was. I was trying to keep the color of the RAM similar to normal. Never, Jim. Everyone should unsub, to be honest. Nuh-uh. All the streams. Peg River Arc. What's a river arc? I'm very confuzzled. I just need the Josh Espanol YouTube to kick off, Jim. That's all, buddy. That's what we really need. River stream. Oh, okay, got ya. Okay, I got you, Jim. What's the max frames on Twitch? For streaming? Probably 60 FPS. Or do you mean for the animation? I think it might be 30. Hang on. Let me check. Cannot be more than 60 frames. There you go. Max size of 4,000 and 96 pixels by 4096 pixels, and as low as 112 pixels by 112. But doing it around like 112 would probably show you more of like what you would see on screen, if that makes sense. For emotes. Yeah, I mean, technically it's the same for both, I guess. I don't think OBS currently lets you do more than 60. Repeat what I said. You accidentally closed the app. So it's 60 frames. 60 frames is max. It cannot be any over than that.
Drama in
You'll fucking get to it. Yeah, Jim. I'm just giving you a bit of a hard time, my friend. Don't worry. It's the same as like me, like bringing up like the TikToks every now and then. I just like to make fun of you guys for it. I'm not all that regular with my like updates either. I've thought about doing more like actual edited videos. I've got a program that I've just yet to install. I literally forgot about it until I just brought this up. I could probably install it like before stream tomorrow, maybe. I should. Well, I've got a couple other things I need to do tomorrow. I don't know. We'll see. We'll see. I still have like a yeah. I discovered I still have the login a few days ago. Oh, you mean for me? Or do you mean for the Josh Parry's Espanol? Because that's funny.
their eye, just because you've enhanced the image, there's only a finite amount of information actually there. But we'll see today, too,
Josh Parry's
that by
and
understanding what's
Espanol.
going on inside of a computer's memory, we can start to represent and even create and code more interesting things. So, for instance, here is...
I really like the idea of you just, like, dubbing over, like, all of my clips and making them, like, completely out of context and just nothing to do with what I said. Like, I really like that idea. I think it's hilarious.
A bitmap, if you will, which is a term of art. A bitmap is a type of image. And it's a map of bits in the sense that you have this coordinate system of top, down, left, right, at least in this artist representation.
You're gonna test run it later? Hell yeah, bro.
Here, and suppose that maybe we all decide as the world that 1 shall represent the color white and 0 shall represent the color black.
Jim, could you change the category for me to software and game development?
What might this map of bits, this bitmap, actually be? Can you see through it? Yeah. It is indeed a smiley face. So an amazing eye. If I actually turn all of the ones to white just to visualize this, you'll see indeed this is what was embedded there. But of course, on our computer monitors and phones, we have this grid of squares, this grid of pixels. So indeed, if you were to actually see on your screen a smiley face, like a black and white one at that, what's probably going on underneath the hood is just some pattern of zeros and ones and maybe single bits, 1-bit color, if you will, where 1 here represents white and 0 represents black. So if you kind of like this thing, it turns out you can do pretty beautiful, pretty interesting, pretty artistically inclined things. If you go to this URL at your leisure, cs50.ly/art, it'll actually redirect you to a Google spreadsheet that we've made in advance, and we've kind of shrunk the rows and columns to resemble a grid of pixels, tiny little squares, all of which are white by default, not unlike this easel here that we have a couple of volunteers working away at. In fact, would you guys like to come forward for a moment and say a quick hello before we come back to you?
Hello, my name is Daniel. I'm from Chicago.
Welcome to Daniel. And?
Hi, everyone. I'm Adam, and I'm from Trinidad and Tobago.
Nice. Well, welcome to you both. Thank you. You'll see that in their hands are actually a whole bunch of pixels, Post-it notes that we've handed them in advance. So if you don't mind, we'll come back to you in a couple of minutes and see what they've created, if you will, on this grid of white paper, much like you could create on this Google spreadsheet. In fact, feel free to send us your creations, if so inclined, via the URL you'll get at cs50.ly/art. Now, let's come back to week 0, where we define some of the building blocks for images. We talked about RGB, which is just red, green, blue, and it's just one of the systems, a popular system via which you can represent any color of the rainbow using some combination of red and green and blue. And if any of you are artistically inclined or have used Photoshop or similar programs, you might typically have some means of selecting a color via some grid like this. But down here, notice, there's explicit mentions of the types of color systems in use, RGB. And in fact, here you see 0, 0, 0. And up here, under New, you see the color black. And that implies that if you have no red, no green, no blue, well, that indeed would represent, by convention, the color black. By contrast, if we play around with Photoshop or any similar program, if you have a lot of red, a lot of green, and a lot of blue, for instance, 255, 255, 255, like really crank it up to the max value you can represent with 8 bits per week 0, well, then it turns out you get the color white here. And we can play with these numbers endlessly. For instance, if we use 255 of red, but 0 green and 0 blue, not surprisingly, the square at the top of the screen becomes, of course, red entirely, because it's all red and no
I would
green, no
never.
blue. If we change it instead to 255 for green, but 0 for red and blue, of course we get green. And then lastly, if we crank up the blue, but leave red and green as 0, we of course get blue. But all this while, down here highlighted, is something that maybe some of you have seen before, like some combination of numbers and letters. If any of you have made personal web pages or used programs like Photoshop, you use these called color codes. So indeed, the world has this convention whereby using 6 digits or sometimes 3, you can represent a little more succinctly some amount of red, green, blue. And you'll see here, maybe by inference, that if RGB is 0, 0, 255 respectively, perhaps where we're going with this is that 0, 0, 0, 0, FF is just an alternative way of expressing the exact same idea. No red, no green, and a lot of blue. But why is that? And in fact, we'll come full circle here to introducing something that we could have done in week 0, but it doesn't really solve a problem then. But today, as we focus more on images and on memory itself, turns out understanding these patterns is pretty useful. So back in week 0, we talked, of course, about binary. And binary, by implying 2, only gives you 2 digits, 0 and 1. You and I, as humans, almost always use the decimal system in normal conversation, dec meaning 10, so we have 0 through 9 instead. If a human like us wants to count up as high as 10 or 11 or 12, we don't have a digit per se for 10, 11, and 12. We start reusing digits. So it's 1, 0, 1, 1, 1, 2, and so forth. But in other systems, not binary, not decimal, but systems called hexadecimal, hex implying 16, there are actually more digits than these, which might come as a surprise. It's not pairs of digits, like in decimal, single digits. And frankly, it doesn't really matter what the digits are, because at the end of the day, these are just symbols that you and I immediately associate with some notion of math, but just strokes on the screen that represent some actual value. So it turns out that by convention, when you want more than 10 digits, 0 through 9, you start using letters of the English alphabet, A, B, C, D, E, and F. And you can represent them in lowercase. It's case insensitive, so it doesn't really matter. You might see it in uppercase or lowercase. But this is how you can count beyond 9, not using decimal, but using indeed something called hexadecimal. If we get really technical, this is also known as base 16. And it's the same idea as week 0, where instead of using base 2 for binary, base 10 for decimal, use 16 as the base for hexadecimal. And so if we run through just some simple examples here, in the world of hexadecimal, your columns are just powers of 16. 16 to the 0, 16 to the 1, 16 to the 2, and so forth. But in the world of hex, we usually, at least thus far and today, we'll see just pairs of digits like this. So here, for instance, is the 1s column and the 16s column, if we multiply that out. So if you wanted to represent the number you and I know in the real world as 0, in hexadecimal, it would just be 0, 0. If you want to represent the number 1, it would be 0, 1. And from there, we get 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. Now things get potentially interesting. In decimal, it would obviously become 10. But in hexadecimal, it just becomes 0a and then 0b. Which is to say, if I rewind, after 9 comes in hexadecimal. If I pronounce it in decimal, this is how you'd represent 10. This is how you'd represent 11, 12, 13, 14, and then lastly in hexadecimal, the 16th value is F, which is just always going to represent 15. So how do we connect this to some of the past math? Well,
He's promoting his OnlyFans chat. Look. Oh dear. Oh dear. Promoting OnlyFans while you're in Harvard. Cancel him. Cancel him!
represent 15. So how do we connect this to some of the past math? Well, once you get to 0f in hexadecimal, if f is the highest you can count, just like in decimal, 9 is the highest you can count, what comes next? If this is 15, I claim, how do I represent 16 in hexadecimal? With what pattern of symbols? What pattern of symbols for hexadecimal? Yeah. So 1, 0, not 10, even though you might read it like that as a typical human, but 1, 0. Because why? Well, even if this is completely new to you, the whole column system, the places are exactly the same intuitively. So you need a 1 in the 16th place and a 0 in the 1's place. And we won't count all the way up to 255, but if we count a little higher, this would be 1, 0, aka 16 in decimal. This would be 1, 1, aka 17 in decimal. And then 18, 19, 20, and so forth, dot, dot, dot. And we can count all the way up to FF. Because if F is the biggest digit in hexadecimal, FF is indeed as high as we can count. And if each F represents 15, well, let's just do the math like in week 0. So 16 times F plus 1 times F is how all of us learn to do math in grade school, even though not in hexadecimal. That's, of course, 16 times 15 plus 1 times 15. Multiply that out, you get 240 plus 15. And ergo, you can count as high as 255 using 2 hexadecimal digits. Now, this is not the kind of thing where this is going to be an interesting exercise mentally to ever convert in your head. Generally, you'll get used to the fact that after 9 comes A, and the biggest digit is F, and you'll just start to see patterns like this in the worlds of Photoshop, web pages in a few weeks, and beyond. But why is hexadecimal useful? Why are we complicating the world and adding on top of decimal something else? Well, it turns out that a single decimal digit, like F, the biggest one, for instance, is 15. And here, let me just propose a bit of mental math. How many bits do you need to represent the number 15 in binary? If you've got the 1's place, 2's place, 4's, and so forth, how many bits total? So fewer than 5 to count as high as 15, I think, but close. Someone else? Seeing a hand? Yeah. So 4 bits, I think, suffice. Because if you want to count as high as F, that is to say 15, I think if you have 4 bits, you can do that. Because if over here is the 1's place from week 0 for binary, this is the 2's place, this is the 4's place, this is the 8's place, do out some quick math. So 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So it turns out that by convenience, hexadecimal digits can just be represented consistently with 4 bits, or fewer, but 4. And 4, of course, is half of 8, and 8 is everywhere. 8 bits is a byte, which is, again, just a convention we've seen. And so the reason that you see hexadecimal in the world of Photoshop and eventually web pages is it actually just maps really nicely to expressing binary numbers more succinctly with a fixed number of digits. So for instance, anytime you see 1111, 1111 in the world as binary, you know what? That's a little tedious to both say and write. You can represent more succinctly any group of 4 1-bits more succinctly in hexadecimal as just F. So 1111, 1111 in binary more succinctly and more commonly now in the world of Photoshop, memory, images, and the like is represented more succinctly as FF. And that's why, because it just maps really nicely to 4 bits. And so we can be a little more succinct. So any questions on hexadecimal, which is just another way of representing information, but using the same grade school approach? Yeah. Good question. If you represent 15 with F, it would use 4 bits. So base systems are really just a way for us humans on paper or on screens to represent information. If F represents the decimal number 15, the computer underneath the hood has to use 4 bits to represent it. So 1 hexadecimal digit, by convention, always implies 4 bits underneath the hood. So therefore, if you have 2 hexadecimal digits, like 00, that means 8 0 bits underneath the hood, like for red or for green. If you see FF Now we know that's 4 1 bits and another 4 1 bits. And if we do out the math, that's 255. That's why in Photoshop, 0000FF means no red, no green, and 255 of blue. And it's just way more succinct than writing out like, what, 8 plus 8 plus 8, 24 zeros and ones. And it's just cleaner than even using decimal when you're using units of 8, which, again, computers just use everywhere. So it's just another system. It's not one you need to dwell on very much. But again, it's fundamentally no different from binary or decimal. We're just using a slightly different base.
Okay.
No, all right, well, we had this blank canvas here. And I think, are you two perhaps ready to reveal for the world what you've created? Do you want to go ahead and I'll swivel it around for you. All right, here we go. Big reveal. And today's pixel art. A round of applause if we could. Very nicely done. Well, thank you both. If you want to come up after and tear this off and bring it home, you're welcome to. And keep the Post-it notes, too. Well, thank you to our volunteers there. Let's now translate this to really more technical world where we're going to see and consider it more often. Because, in fact, sometimes when you've had error
What the fuck?
a few weeks from
Among Us. Among Us.
playing the compiler, you might have even seen evidence of hexadecimal. We didn't call it out. It wasn't useful to know at the time. But it turns out a lot of programs use, and a lot of code uses hexadecimal for those reasons of more succinct representation. So for instance, where else might we see it? Well, here's that picture we keep pulling up.
You look away for 5 seconds and there's Among Us on the screen. Exactly.
Of our computer's memory, and each of these squares in this grid represents a byte, sort of top left to bottom right in the computer's memory. But again, just an artist's representation. A few weeks ago, I claimed that each of these bytes can be numbered, of course. Like this is byte 0 at top left, then byte 1, then byte 2, then byte 2 billion if you have 2 gigabytes of memory. And so we could just number them like this, 0 through 15 on up. 16, 17, 18, and so forth. But per the reasons earlier, it's just more common in computer systems and software to actually use hexadecimal just to describe the locations of, the addresses of things in memory. So instead, a typical programmer or computer scientist would call these first 16 bytes 0 through F. Just because, but that's because it's a predictable number of bits. So if we keep going beyond that, you would get not 10, not 11, not 12, but in hexadecimal, 10, 11, 12, and so forth, all the way down on the screen to 1F. And if I shrunk this down or had a bigger monitor, we would see eventually 255 bytes later from the start, 255 as well. But there's a potential problem here with using hexadecimal in this way. There's an ambiguity. Can anyone imagine what can go wrong if we use hex to just simply describe locations in memory like this? Yeah. Yeah, like 10 might also be 10. And, maybe if you're, really thorough, OK, wait a minute, it can't be 10 because here's F over here. So it's obviously not decimal. But why create potential confusion, especially when you're collaborating, building something with someone? We want to avoid that ambiguity. And so the convention humans decided on years ago is that if you want to make clear that a number is in hexadecimal, just by convention, you prefix all of the digits with 0x. The X is not like another character. It's not like a 17th character. It's just a human convention of putting 0x to imply here comes hexadecimal. And now it's unambiguous. So now we see 0x10 obviously is not 10 as we know it in decimal, but rather it's the number that comes after a single F. So it's really the number in decimal 16. So 0x, anytime you see it, that's just a visual cue that what is ahead is actually hexadecimal. So let's now start playing around with this information. So here's a super simple line of code from week 1 where I'm just declaring a variable n, and I'm defining it to be the value 50. And this is out of context. We probably need a main function and all of that. But let's just rewind to week 1 where we actually saw code like this and do something useful with a line of code like this. So let me go over here to VS Code. And in VS Code, I'll create a program called, how about addresses, since the goal of this, the goal here is to just play around, ultimately with a variable like n. And let me go ahead and do this. I'll include, how about standard io.h. I'll do int main void, so no command line arguments for now. Int n gets 50. And now, so that we can do something mildly useful with it, let's just go use printf and print out with %i, and then a new line, whatever that value of n is. So this is not going to be interesting per se. It's just week 1 stuff where I'm defining a variable and printing it out to the screen. So let me go down to my terminal window and do make addresses. No errors, so that's good. I'll do /addresses, and of course, I should see the number 50 here. Now, what's going on underneath the hood? Let's translate now code to really what's going on underneath the hood of the computer. So if this is our grid of memory, I don't necessarily know as the programmer, and I definitely don't care as the programmer where exactly it's ending up in memory. That's the whole point of using code. Let the computer figure this out. But at least conceptually, I know that by declaring a line of code like that, the number 50 ends up somewhere in the computer's memory, and it's assigned the name n, a symbol n, via which I, the programmer, can refer to it. And I very deliberately used 4 of these squares for what reason? What might be the reason for using 4 squares specifically? Yeah, so an integer is 4 bytes. At least most of the time on modern systems, an integer is 4 bytes. On an older computer, it might just use 1 or maybe even 2 bytes. But here, by convention, we're almost always going to see 4 bytes. I don't know if it's going to end up here. It might end up over here. But for now, who cares? I just know that the computer can store the information in this way underneath the hood. So let's now introduce another feature of C that we haven't had occasion to use just yet that's going to allow us to start poking around the computer's memory, for better or for worse. And this is one of those situations where you're about to acquire a skill, a power that can actually come back to bite you. Because once you know how to start poking around a computer's memory, you can do very powerful things. And next week, we'll see what you can build in a computer's memory. But you can also screw up pretty easily and cause more of those segmentation faults that a few of you have already suffered. So with that said, let's just stipulate that, you know what, I don't care necessarily where the 50 is in memory, but I know it exists at some address in memory. And just so I have an easy address to pronounce, let's just suppose it lives at 0x123. So that's the address in memory in hexadecimal by convention, and that just happens to be where it ends up when I write that line of code. But it turns out C has some other operators we can use. When we've seen the asterisk before, the star, and we've used it for multiplication. But today we're going to use it for something more powerful. And we're also going to introduce an ampersand, which allows us to do something as well. The ampersand operator is going to allow us to get the address of a piece of data in memory. Like by literally putting ampersand before the name of a variable, C will tell you what address that variable lives at. Maybe it's 0x123, maybe it's 0x456, who knows, but that will give you back the answer. The star does the opposite. It sort of means go there. So using the star, otherwise known as the dereference operator, I can actually go to a specific address if I want. And we'll see what this means in code. So how can I leverage this in some mildly interesting way to start poking around, but eventually we'll use this primitive to build more interesting things. So let me go back to, say, VS Code here, and let me go ahead and do this. I'll clear my terminal to start fresh, and I'll introduce another format code for printf, %p. And for now, just take on faith that it is %p because, but %p is going to allow me to print the address of a variable if I additionally tell C, get the address of n. So I'm changing %i to %p, and that's just something you have to do when printing addresses for now. But I need to change an ampersand in front of the variable name, so I don't print n, the number 50. I print out something like 0x123. And it's not going to be as simple as that. We'll see on the screen, though, where it actually ended up in my code space's memory. So here we go. Down in my terminal, make addresses again to
Number
recompile.
15,
And now,
Burger King foot
/addresses
lettuce. The last thing you'd want in your Burger King burger is someone's foot fungus.
True. Not the foot fungus. Hey, Squid, how you doing?
should reveal not the value of 50, but the address of 50. And there it is. It's pretty long. It's not quite as simple and pretty as OX123, but there's the OX, meaning here's a hexadecimal address, and it's 7F, FC, C784A04C. Suffice it to say, your code space, and even your Macs and PCs nowadays have a lot of memory. That's why, in part, this address is so big, not as small as the thing on my slide. So this, at the moment, isn't that useful yet, but it introduces us to a concept that we'll now call pointers. And pointers are admittedly one of the more challenging aspects of C. And if in future life you tell friends that, oh, I took a class called CS50 and we learned C, like you'll probably get kind of a look at people like, why did you learn C? Or like, oh, C was hard. And it's largely because of this topic, which isn't to say that it's that hard to wrap your mind around, but it's definitely very different, and it's not a feature that you can harness in higher level languages that we'll see in class 2, like Python and Java and the like. C is about as close to the computer's hardware, so to speak, that you can get before things get actually scary. The so-called assembly language we saw in week 2 when I had to link and compile and assemble and all of that. Like that.
He's talking too much about 50, but not enough about 15. Oh.
Gets really low level, and you really have to be an expert with the computer's CPU or brain to understand that. But with C, you can actually poke around the computer's memory and do powerful things with that. But again, with great power comes responsibility. It's very easy to break programs by misusing memory or just having a bug that touches memory in some way that you don't intend. So pointers, at the end of the day, are pretty much what we just saw. A pointer is really just a variable that contains the address of some value. A pointer is a variable that contains the address of some value, or more simply, it's easy to think of it as an address. A pointer is an address of something in the computer's memory. Now, what might we do to actualize this? Well, here's 2 lines of code. It turns out, by using our 2 new operators today, I can declare an int, call it n, and assign it a value like 50, just like before. If I want to store the address of n in a variable and not just print it immediately via printf, I can declare a variable, for instance, called p, but I could call it anything I want, like any variable. But because it's an address, it's not int p. It has to be int star p, so to speak. And the star here on the left-hand side of the equal sign is just a clue to C that means p is going to be a pointer. That is, p is going to be the address of what? The address of an integer. Now, technically, it's still an integer itself, right? Because an address is just a number, whether it's 123 or 0x123. So this is really just a semantic difference. So int star p just means that this variable doesn't contain any old number, like 50. It specifically contains a number that is the address of something else. So how can I now use this? Well, let me go back to VS Code, and let me propose that we add a line of code like that. So instead of just directly printing out that value, let's go ahead and define a second variable called p that's of type int star p, set it equal to ampersand n, and then this time, let's not just print out ampersand n, let's actually print out the value of p. So the only 2 new things here, if I zoom in, are I've used not only the ampersand on the right to get the address of n, I'm now using the star on the left to tell C that p is still a variable as always, but it's a pointer. It is the address of some other value like this. And I'm still going to print it with the same format code, %p, so that doesn't change. So let me go ahead and zoom out and do make addresses and /addresses. And there it is, exactly the same thing. Now, in and of itself, not that useful yet, but the fact that you can now access the addresses of things in memory means that we'll be able to build things and construct things and link things together by knowing where they live, so to speak. So any questions on this technique thus far? Yeah? A good question. On line 6, must it be star p and ampersand? And in this case, yes, because what am I doing? On the left, and I'll get rid of the equal sign for now, this would give me a variable called p that's not an integer per se, but that's the address of an integer. But without the equal sign, I'm not storing anything in that variable. So by adding the equal sign and then ampersand n, I am explicitly figuring out with ampersand what the address of n is, which already exists per line 5, and tucking it away in this new variable called p. Other questions? Yeah? Good question. Every time I run the program, it uses up a different piece of memory. Short answer, yes. Computers, though, long story short, also have something called virtual memory. So if you run it again and again, you might actually see the same addresses on the same Mac or PC or cloud-based server. But we'll see in a bit where, at a high level, it's laid out. But it will always exist at some address. Good question. Yeah?
Hello! Yeah? Can I do it? Yeah? Ah. Bye. Do I work on anything while watching these or after? Yeah, I work on stuff a little bit like after. Um, At the moment, I'm trying to wrap my head around this a little bit more. I would definitely prefer, what do you call it? Some prompts. I was meaning to look at the website you mentioned. I've already like signed up to it, but like it was a lot of like intro shit that I got super bored of and I was skipping through. It was just talking about like what it was that we were going to learn in it. And I'd rather just skip to the learning part. Hi. Hey, Will. How's it going, buddy? Hope you're having a good one.
Correct. Ampersand n is the address of n, and int star p is a pointer called p. And honestly, in an ideal world, if C were made today and not decades ago when humans were first creating languages, you know, ideally, we would just...
We're not even halfway through the class. No, buddy, this takes an entire day. Okay, I'm not sitting through this entire class today, so don't worry about that, Jim. Okay? The plan was always to do some of this and then move on to Elden Ring or other games. It's just like I don't want to overdo it. Of course, if you don't practice it, it'll just go in one ear and out the other. Yeah. Like, so I've done some of the stuff before. And it's a good recap. Like we're hitting the stuff that I haven't looked into all that much. Like the hexadecimal thing is new for me. And you knew it was a day. You just thought we had spent more time on it than we have. Bro, we've spent 9.5 hours in here, Jim. It's not a little bit. Feels longer? Maybe. We must keep going. Which, just for reference, Loco, which one did you sign up for when you first did one of these? Like, the introduction sort of stuff? Because I'm starting to wonder if, like, I picked the right one. I think I did, but I'm questioning it now.
Have a data type called pointer, and then this would be a little less complicated because it would literally be what it says. You know, the humans who invented C didn't do this, but this is the idea. So pointer is not a legitimate word in the code. It is a term of art in English, but this is really just the idea. But the way you express pointer...
Have you ever seen on YouTube, Morshu reads the entire Bible? It's 3 days long. Who the heck is Morshu? And no. I've just seen like memes of like left ear listening to like the Chinese Bible and the right ear listening to, I forget what, something else. You did the Harvard Python one, since it's the same professor you're watching right now, and he's great. Oh, that's cool. Hell yeah, Loco. You skipped CS50 since you go to school for that. Fair. Completely fair. Is it on the website that you told me to look at, Loco? Because I'll sign up for that one too then. The shop guy from the Zelda CD games. Sorry, Link, I can't give credit. Come back when you're a little richer. Yeah. Is that right, but
as a data type is a little more cryptic as int star p here. But notice, in line 7, when I print out p, I don't use a star, I don't use an ampersand y, I literally just want to print the value of p. And we've been doing that since week 1. If you want to print a variable, just describe the variable by its name. No special syntax. Any other questions on this?
Fuck.
What's the advantage of using pointers? With pointers, we'll see today some applications of...
Yeah, buddy. You have to give me a minute for that one.
them. Really, the idea is going to come to fruition next week when we're going to create what are called data structures in memory, where we can build not just, for instance, one-dimensional data structures like an array. We'll see next week we can actually create the equivalent of two-dimensional data structures or even three-dimensional data structures by using these addresses and sort of linking things together. And we'll see the beginnings of that this week. But for now, focus, at least for now, on just really the syntax and what these building blocks can do for us. Does the p pointer have to be point to an integer? Short answer, no. And we'll come back to this. For now, for the sake of discussion, we're only dealing with integers, like the number 50. You mentioned strings or characters. Absolutely. We're about to go there soon. So you can use the address of anything you want in the computer's memory. So in fact, let's translate this now to just the same picture, just to help you wrap your minds around what these two lines of code really fundamentally are doing. So if I come back to my grid of memory here, let's plop the number 50 in the variable n at the bottom right, like it was before. So this is that first line of code as before. But with the new second line of code, as soon as I create p, what do? Well, first, remember that n lives somewhere in the computer's memory. Usually, I don't care precisely where it is. But for the sake of discussion, let's suppose it's at 0x123, which is easier to say than where it actually ended up. And now, what is p? Well, p is just another variable. And variables live in memory, too. So let me just hypothesize that p lives up here. And it turns out that p, once you assign it, the value of ampersand n means that c will take a look at the variable n, realize, oh, it lives at 0x123, and what goes in the value of p is literally 0x123. So again, it's still an integer, which is confusing, but it's technically an integer being used as an address. And now, just a prompt here, notice that this pointer is pretty darn big. It's like 8 squares. What's the implication of that? Because I did that deliberately. How big must a pointer apparently be in most modern systems, would you say? OK, good. Computers today are very big. You have gigabytes of RAM in your computer. You therefore need big pointers to be able to point at memory that's conceptually pretty far away. So to be clear, how many bytes does a pointer apparently take up? Well, it seems to take up 8 in total. Integers by convention nowadays are usually 4. Pointers, though, nowadays are typically 8 in this case. So I'm drawing it in a manner consistent with the reality, even though at the end of the day, it's not really that interesting what values are in here. In fact, let's emerge from these weeds. I don't really care what else is going on in my computer's memory at the moment, because I've only got those 2 lines of juicy code defining n and defining p. So let's hide all of the other squares. And honestly, I mean it when I say that programmers need to know that a variable exists somewhere in memory and needs to be able to get that address using like the ampersand, but you're never going to printf like I did the actual address. Like, it's not generally interesting unless you're debugging your code, but you're not going to like start typing out crazy OX numbers in your code to move things around. You just need to know that the computer can figure out where things are. So frankly, by that logic, who cares that it's 0x123, right? Tomorrow it could be 0x456 or something else. So one of the ways to think of a pointer is literally as a variable that points at something else. And indeed, in this case, p, yeah, technically it has an address, and yeah, technically it's 0x123 in the story. But honestly, who cares? I just need to know that using p, I can get to the value n. And so what are these addresses? And in fact, if Carter wouldn't mind joining me up here for a moment, what are these addresses? Well, just like in our human world, we have mailboxes, even though you might not check it very frequently nowadays. But to get physical mail, every home, every business has a unique address. The Science and Engineering Complex is 150 Western Avenue, Austin, Massachusetts, 02134, USA. And theoretically, that uniquely identifies that building in the world. Well, here we have 2 mailboxes. Over here, we have a value n that happens to live, I'll claim, at address 0x123. And then over here, I claim there's another address called by name p. I don't actually care where it is, even though it definitely exists somewhere in the computer's memory. But if this is p, which is a variable, and that's n, another variable, ideally, this mailbox would be twice as big because of the number of bytes using, but Home Depot only had identical size mailboxes. But here is p, one variable. There is n, another variable. If I open up this mailbox, what should I find inside of it based on our story thus far? Like, what value will I pull out dramatically in just a moment? Yeah, I think OX123. Now, using this, you can kind of think of this as like X marks the spot, no pun intended, where I can now like walk around the computer's memory and find my way to that location by sort of following the treasure map. Or if I want to more dramatically, thanks to our little nail foam finger here, you can think of it more abstractly as P is just pointing at N. Okay, that's not going over well, so let's switch over to the Harvard one. So P is pointing... So P is pointing at N, and so it turns out we will be able to write code now that will do the equivalent of me walking over to N. But for now, Carter, if you want to reveal what's in the mailbox, we should see, indeed, the number 50. So that's really all that's... Oh, I feel Carter's waiting for applause. So, like, really, well, nicely done. Thank you. So that's just like a physical metaphor of what's going on here. In one variable, we have an address, and that variable by convention is called a pointer. In the other variable, per week 1, we just have a value like N, and you can, yes, follow the map and walk yourself to that particular address, and we'll see how to do that in code. But what's really interesting is this abstraction, that pointers literally, or really, I guess, figuratively, point at some other value in memory. All right, questions then on pointers in this form. Can pointers point to each other? So yes, there's things called double pointers. We're not going to see them anytime soon, but using star star, you can express an address of an address, but we won't see that just yet. Other questions on pointers?
Okay.
Yeah, in front. Are arrays, so to summarize, are arrays then pointers? So short answer, there's a relationship, and we'll come back to that in a little bit. But arrays are technically different from pointers, but we're going to be able to blur the lines a little bit by using one like the other. But let me come back to that in just a bit of time. All right, so if we have now this mental model, if you will, of like what a pointer is in memory.
Give me a minute, chat. I need a potty break. You've completed 2 frames page. Hey, let's go. This is hard. Oh yeah. I studied animation for a while, Paige. It is very hard. It's very time consuming. Just for reference, you don't have to literally do 60 frames worth of animation. It will look ow. It will look fluid if you do it that way, but it's not necessary. You could skip 2 to 3 frames. Depending on how, like, quick the animation is. Okay? If you want some advice. If you want to just do it your way, do it your way.
I think we can start to peel back a layer of simplification that we've been assuming for the past few weeks since week 1. So a string, recall.
It's going to take you a while. It is. I was never planning on 60 frames. I like living. Animators quite often do like 24 to 25-ish frames, sometimes 30. Just for reference. Per second, by the way, because it's doing 60 frames per second. So they would just do like, yeah, and then they would still skip a couple frames. I'm not sure what your plan is. But you've got this. Break time! Yeah? What are you gonna break?
Is a sequence of characters, and so if you want to create a string that says hi in all caps and an exclamation point, we do string s equals quote unquote hi, and we can hard code it like this, or we could use getString, but for now just assume that I hard coded it into my code to always say hi in all caps with an exclamation point. Well, what does that look like in the computer's memory? Well, let's stop looking at the entire memory. Let's just focus on really what's going on. Once
I plan on doing a bunch of frames in the beginning, showing her nodding off, and then quick slam. Just like the stubborn. Yeah. That's pretty cool.
you create a string called s and store in it hi, you know that a couple of things are happening. H and I and the exclamation point are ending up in the computer's memory. We know from week 2 that this thing, the so-called null character, NUL, aka \0, is also being added for you. And it's somewhere in memory. At the moment, I don't really care where. I drew it at the bottom right. Yes, it has an address. But for now, it just ends up somewhere. And in fact, here's a little visual cue as to how this happens. In C, anytime you use double quotes to give you a string, you can imagine that the double quotes are like a clue to not only store HI exclamation point, but also put the null character there for you. And this is in contrast to what? Chars, if you want individual characters, what syntax did we use instead? So single quotes. Single quotes do not add magically a \0. They literally just store one character. So again, strings have always been a little special. You get an extra byte for free so that you know where the string ends, and functions like stir compare can then find their way there. So in memory, it might indeed look a little like this. And if we assume that there's going to be somewhere in memory, these things are going to be somewhere in memory, we can address them per week 2 by way of the name of the variable. So if s is the name of the variable, s bracket 0 is how you would refer to the first letter, s bracket 1, s bracket 2, and if you really want, s bracket 3 would get you at the null character at the very end. But what is s? So technically, in this line of code here, not only is the computer giving you memory for HI exclamation point \0, it turns out that s itself must take up some amount of space, right? Because s is the variable. And every time we've talked about variables thus far, I've given you a rectangle on the screen in which to store its value. So let's assume, for the sake of discussion, that the h is at 0x123, and I is at 0x124, exclamation points at 0x125, and the null character is at 0x126. Well, what then is s? Well, s is just going to be some other variable, and I'll draw it somewhat abstractly without all the other boxes up here. And I'll claim that the name of this variable is s. But it turns out, what is s really? How do strings really work? Well, s is a variable and has been since week 1. But when you define it, what the computer is doing for you automatically is when it knows you want to store hi exclamation point, it puts that somewhere in memory. The computer then figures out for you what's the address of the very first character, and it stores that address and only that address in the variable you created on the left-hand side of the equal sign. And that's enough. Like, to represent a string with 3 letters of the alphabet or punctuation, you don't need 3 variables. You just need one. You just need to know the beginning of the string. Why? Why is it sufficient for a variable to only store the first byte's address and not all of the bytes' addresses? Exactly. Because of the design of strings per week 2, we always null terminate them. So it suffices to only remember the first byte's address, because from there you can sort of follow the breadcrumbs, byte after byte after byte, and until you see the new line, the null character, you know that all of those characters are apparently part of the same string. So this is what's been going on in the computer's memory all since week 1. And in fact, if we abstract this away, you can really think of s as being just this. Really a pointer to that chunk of memory. So in fact, what do we have here? Well, in the left, to recap on the code here, on the left-hand side, string, that's what ensures that we'll actually be able to store a string in a variable called s. We're going to have on the right-hand side, though, the actual value. So let me switch back to VS Code here, and let me change my code to no longer involve integers alone. So I'm going to add the CS50 library, just so that I can use some shortcuts in there, cs50.h. And then in my main function, I'm going to go ahead and do this. String s equals, quote unquote, hi, in all caps, exclamation point. And then I'm going to go ahead and print out, using %s, as always, \n, the value of s. So this program at the moment, not interesting at all. It's just week 1 stuff again. /addresses indeed prints out hi. But it turns out that now that I know this, what's really been going on underneath the hood all this time? Well, here's that same line of code that defines the variable called s. And it turns out, anyone want to guess what string is actually a synonym for? String, it turns out, is kind of a white lie we've been telling since week 1. There is no such thing as string as a keyword in C. It's technically a CS50 thing, yeah? It's a pointer to a character. So really, all this time, we've kind of been lying to you. There is no string, quote unquote. It's actually char star. And if I may, dramatically, here go the training wheels. Like, OK, that didn't land very well. So what have we been doing? Well, it turns out that string is a much easier way conceptually to think about what a string of characters is. Like, my God, if we had to start in week 1 by having you type char star, like, yeah, you might get past it. But like, this is just way too much ugly syntax, not intellectually interesting at all. So we abstracted away what a char star was in the first week of C by telling you it's actually called string. Now, string is a term of art. Like C programmers in any language will use the word string to mean a sequence of characters. But in C, it's not technically a word unto itself. It's rather a synonym that we are.
That's not healthy. Wait, what's not healthy? What are you talking about, Jim?
Ourselves created in some form. So in fact, how did we do this? Well, think back to just last week. Last week, I proposed that it'd be really nice if we had a person data type, which the creators of C did not think of decades ago. But that's OK. We can define it ourselves. What did we do here? Well, we're using syntax like this. Recall that we defined a person to be what? To be this structure. This structure, using the new keyword last week, struct, means that a person is just a name and a number. And it could have been other things. We just kept it simple. But how did I associate person with that structure?
That amount of crunch? What? Am I missing something? What do you mean? Huh?
Well, we claimed that it was this value here, typedef, which, as you might expect, defines a data type. So what did we do as CS50 back in week 1 without telling you? Well, we could have done something like this. Like int itself is a little cryptic, and maybe we should have, to keep things even simpler, said, hey, everyone, turns out you can define integers in C. And if you wanted to do this, well, if you want to create the keyword integer as a data type, you can just typedef it to int. So typedef creates the word on the far right, integer, and creates a synonym for it, in this case called int. So what did we do in week 1 without telling you? We have a line of code like this in the CS50 library that associates quote unquote string with, more cryptically, char star. And this is why in week 1 onward, anytime you use the CS50 library, you can write the word string as though it's a real C data type. And that's just because we wanted to have this abstraction, these training wheels on for the first weeks, so we don't have to get in the weeds of all this crazy memory stuff. We can sort of talk about strings at a higher level. But that's all they are. Strings are the address of the first character in that sequence of characters. Questions now on any of these details? Yeah? Good question. What about the strings library, which we have used? Unrelated. So it does not define the word string. Everything in there actually relates to char stars. And so in fact, if you've used the CS50 manual, which is just our user-friendly version of the actual manual pages for the official language C, you'll see throughout that now, if you start poking around or turning off less comfortable mode, you'll actually see that we changed any mentions of char star in the official documentation for these first weeks to just string, to simplify it. But underneath the hood, C does not know the word string per se as a keyword, but it's absolutely a concept that like every program in the world knows about. And in fact, in other languages, in Python, for instance, there will actually be a proper string, although it's not going to be called string. It's going to be called str, S-T-R for short. Questions on these strings here? Well, let me propose there's one other feature of this syntax that we can now leverage as follows. Let me propose that if we go back to the previous version of my code here, wherein, let me switch back to VS Code in just a moment. I'm going to rewind in VS Code to the integer version of my code from before. And most recently, it looked like this. Before, when we were using integers only and not, in fact, strings at all. Let me propose that there's this other feature of C that we can use that actually allows us to go to an address. So at the moment, let me just rewind and do make addresses to remind you what this program did when it was using integers alone. And there's that address. Why? Because on line 7, notice, I'm printing out the value of p, which is a pointer, so of course it's going to look like an address. But let me zoom out now and make one change. Instead of printing out p, how can I use today's second new operator, not the ampersand, but the star, to actually go to that address? Well, what I can actually do on this line of code is this. If I want to print out the actual integer 50 that's in that variable, or equivalently at that address, I can go to p here and not print p literally, because that's just an address. I can now say star p. And star p means go there. More technically, dereference p. That is, follow the treasure map to the actual address and do what Carter did, open the mailbox and print whatever was in the mailbox, which recall was the actual number 50. So let me try this. Let me recompile the code. So make addresses. Okay, let me clear my terminal window, /addresses. This time, I shouldn't see the OX anything. I should see just the number 50 in this case. And here, too, is kind of an unfortunate design decision, certainly pedagogically, I would say, in C. If I zoom in on this code, star is unfortunately being used in 2 different ways. In an ideal world, they would have used 3 different symbols to make this more semantically clear. But this is what we're stuck with. So in line 6, when you declare a pointer, that is a variable that stores an address, you put the type of variable that you want to point at, then a star, just because, and then the name of the variable. And then on the right-hand side, you actually get the address of whatever using ampersand. But when you want to go to an address, you want to dereference a pointer, you don't use int again. And we've never done that, right? Once you declare a variable, you never again mention the data type. But in the world of pointers now, if you want to not print out p, but go to whatever address p is storing, you use star p here. So a good visual indicator would be when you declare a pointer, that is, make it exist in your program, you have to declare the data type with the star. But when you use a pointer, you just use the star. In an ideal world, this would be a completely different symbol. But again, this is what we have. Questions now on that syntax? Yeah. Why can't we just do the ampersand here, are you saying? It was still a little quiet. So strictly speaking, we do not need line 6. So this is really for pedagogical sake that I am defining a separate variable p and then printing it out. At this point, though, I'm just kind of, going in circles, if you will, because more simple would have been what I would have done in week 1, which would be get rid of p altogether, get rid of p here, and just print out n, right? But today, we're just giving you this new building block, this new syntax, via which you can figure out the address of something and then reverse the process later and actually go to it as well. Other questions on what we've done here with these pointers? All right, well,
I get that, but I can't figure out. I can't figure out what it's used for yet. Like, I understand this, but I don't understand, like, what it's useful for. I assume he's gonna, like, tell me as we move on.
let's context switch back to the string now and see what more we can do with this here. In the case of our strings here, let me refine this to zoom out. Let me delete the integer related code here. Let me do string s equals quote unquote hi in all caps. Let me go ahead and for the moment include cs50.h at the top so that indeed I can use the keyword s, or string rather. And let me go ahead now and do something more than I did last time. Last time I did printf of %s\n, and then I printed out s. And again, I'll recompile this just for clarity. Make addresses, /addresses, that just prints out hi. So that's, again, week 1 stuff. But now that we have this other bit of syntax, we can do some interesting things too. So for instance, suppose I want to print out not s itself, but what if I want to print out the address of s? Like, at what memory location is s? Well, I can change my %s to %p, which now we know p is for pointer. So %p means print out the value of a pointer. That is an address. And here, I can actually print out s itself. But why that is, we'll see in a moment. Let me do this. Here go the training wheels. String does not technically exist, but it does if I'm using the CS50 library. But if I get rid of the CS50 library, as I'm metaphorically doing by taking off the training wheels, I can't use the word string anymore. And in fact, let me make this mistake deliberately, as you might have accidentally in past weeks. Here's the error message I get if I forget the CS50 library. Use of undeclared identifier string. Did you mean standard in? It's trying to be helpful, but it's not, because I didn't mean standard in. So indeed, this is confirmation that C does not know the word string exists, at least as a keyword. Exists as a concept, but not a keyword. So I could fix this by adding back the CS50 library, but that's kind of a step backwards educationally as instead of a step forward. What could I do instead to fix this now, if the training wheels are now off?
Just yeah. Right?
Exactly. Replace string, quote unquote, with char star instead. So I'm going to go ahead and change this to char. Technically, you can put the literal star here, the asterisk, or you can put it there, or you can put it here. By convention is to do what I'd done from the beginning, put the star next to the name of the variable as opposed to anywhere else. Let me go ahead now and, or sorry, I meant to add the spaces there. You could do this too, but this would be the most normal convention. So now let's do this. Make addresses. Compile's OK now. /addresses, what should I see? Hi or something else? Feel free to just call it out. So still hi, you say? Someone else?
Well, is it going to be the address of it?
A memory location. All right,
yes.
So it could be one of the two options, right? Either I'm going to see the string or I'm going to see a memory address, though I do in fact see a memory address, and this one's quite different from the integer one. But does anyone now want to explain why you were correct? Why am I seeing the address down here and not hi? It's subtle, yeah. Exactly, because I left my %p there, which means, hey, printf, show me a pointer. But this is where printf is smart and has been smart since week 0. Humans who invented printf decades ago wrote code that notices that, OK, %s means to treat the following value, not as just an address per se.
Hey, Sneaker. El Joshua de Paris. ¿Cómo estás, señor? Hello. How goes the thing, Sneakers? I hope you're doing well, buddy.
That gets printed literally, but print it, as with the mailbox demo, is sort of a treasure map that leads you to
what have you been up to?
Of a character. So simply by
yeah, you're really, really obsessed with this dress to impress thinking what I don't even know if I got that right. Huh, Paige? You just Roblox obsessed at the moment, huh?
By changing one character, %p to %s, and if I now do make addresses again and /addresses, this now is identical to week 1, but hopefully makes sense because
You're just chilling? Funny enough. You typed sexiest Twitch streamer and got here. Yeah, well, thank you. I do appreciate your funny little white lies, but they make me feel better. How you doing, buddy? We're still. Oh, I'm assuming you've gone through the Elden Ring DLC, my friend, by now. Cool. I actually do not remember if you've said you've been going through it or not. Ah, sorry.
s is just a clue to printf that means
You never played Elden Ring? Wait, you haven't? Huh. What have you been jamming then, bud?
go to this address in s, will print out every character there and thereafter until you see what? The null character, and then stop printing anything more. And this is why hi has printed since week 1. Today we can see the address %p, but this combination of having access to addresses and the null terminator is all the information printf needs to actually do something more useful by like printing the actual strings. Any questions now on this approach to %s?
You know you're a terrible Souls fan. If I get into it, I will turn so white for not going out at all. I know it will consume my life. That's okay, my friend. I understand. I understand. It has consumed a lot of my life, to be fair.
Yeah, in back. Oh, so why is it traditionally being used in this way? Honestly, like the word string has been around for decades. It's not a keyword you should be able to type in C unless you're using a library like CS50s. And so %s just means string. So even though it doesn't exist as a keyword, %s connotes string. And humans decades ago, like today, just kind of know what that means. So they could have chosen any letter of the alphabet, but S sort of makes the most sense. All right, well, let's, in back. Other question? Good question. Before, let me zoom in. I did not use a star before the S. Why? Well, it's subtle here, but printf was invented years ago to know, given an address, like in the variable s, printf knows to go there. So if we looked at the source code that some human wrote years ago for C, we would likely see the actual asterisk that you're referring to. Printf is taking on the responsibility for going to S. If you were to do star S here instead, an asterisk and then S, that would now be literally a character. Because if I say star S, that means go to the address in S, and all you're going to find there is a single character. What printf wants to know is not what is the character there, what is the address of that character. Why? Because printf needs to walk through the rest of those characters looking for the final null character. And in fact, let me see with a bit more syntax if we can highlight this a bit more. Let me do this. In addition to printing S, let's try out our syntax in another way. Let me print out with %s. How about...
You would much rather me play it and parry mofos to death? So we're still technically on the last DLC boss, Sneakers. I am predicting I beat it today. I'm really, really close. I even like... I mean, you can see that now. It's not super noticeable because it's not super big. But I've got the controller thing so you can see if I move anything. Because there's been a couple of points where, like, I swear I've been doing, like, the correct inputs and I still die. So, like, I might not have actually been doing them. I might have just had it been, like, slightly off. Which is, yeah, that's probably what's happened. So I'll feel a lot better about it if I see I'm just being dumb. It's literally for me, and then you guys happen to get, like, a positive by seeing what buttons I push.
About, not S here, but let's print out some addresses. %s, \n, close quote, and then let's print out, how about this? The first character in the string s would be called s bracket 0, but how do I get the address of the first character in s? Well, I could technically just use today's new primitive. I can just add an ampersand. That always gives me the address of some value. So when I end this thought and clear my terminal window and run make addresses, still compiles. When I run addresses in just a moment, any guesses as to what I will see line by line? This will print out two things. And you don't have to remember what the actual number was, but at a high level, what will be printed now? The same thing twice. Why? Well, when I run this, what I'm printing here, and let me zoom in at the bottom, I indeed see two really long addresses, but they're in fact the same. Why? Well, that's because, again, if s is the address of a character, as implied now by either the CS50 word string or the actual phrase char star, well, then s is just an address. By contrast, per week 2, s bracket 0 is a char. Always has been a char, a specific char. But if you want the address of that char, you just add the ampersand. Well, it turns out that strings, per the definition we keep emphasizing, is just the address of the first character in a string. So of course, if you do this, you're going to see the exact same thing. And if I do this a bit more, generally you don't want to copy paste, but this is just for visualization's sake. Let me print out all of the characters. So another, and let me change this to print out the address of bracket 1, bracket 2, and bracket 3. So all 4 characters, HI, exclamation point, and the null character. Notice I'm using %p for all of them. So if I now do make addresses and /addresses, now notice, and this is kind of cool, the first 2 are indeed still the same, but what's noteworthy about the other values on the screen?
We'll go up
Yeah,
by
they're
1.
consecutive. Each of these is just 1 byte away. Even if you're not good at hex yet and there's a crazy number of digits here, who cares? They're all the same except for the last ones. 4, 4, and then 5, 6, 7. And this confirms what I've been claiming for weeks, is that in an array, all of the characters are back to back to back, contiguous, 1 byte away. So with just this ampersand, with just this star, like, it's actually a pretty cool tool in the toolkit to have, because you can start to poke around what's actually going on inside of the computer's memory. And in fact, if we do this, I can introduce one other cool trick here, if you will. Let me propose that we can actually now do arithmetic on pointers.
Okay. This is where I'm going to pause the learnings, because I think we've done enough for today. I've been having a lot of fun with it. But we are going to jam some Elden Ring when I get back. I gotta quickly check on something. You guys be good in the meantime, okay? Hello. Um, I hope we're doing good. Putting on some socks. Could one of my lovely mods please change the game type to Elden Ring, please? Cool. Eh, gross. Cool. Back. Hi, back. I am Josh. How are you? It's time, Timothy. Yeah. Fuck yeah, I did it. Yeah. Fuck! I finally did it, and fuck! That was so, like, unenthusiastic, too, when I said that. Fuck! Big Sag. Where's Shady when I need him, man? He would totally clip that for me. Get wrecked. What? That is some rude bullshit right there, Peg. I'll have you know
Number
that...
15, Burger King foot lettuce.
Yeah?
The last thing you'd want in your Burger King burger is someone's foot fungus.
Yeah? Rude. Interrupting me like that? Imagine.
Damn you, Samaritan!
What, now is it just time to, like, do all of the fucking, like, redemptions all at once, huh? Fucking rude. Why is that one still only 20? Okay. Okay. Correct? Because...
I don't want peace. I want problems, always.
I ain't fucking around anymore, Josh. Watch Bluey. Watch it now.
Yeah?
Be gone, sucks!
Yeah? Are we done? Is that everything? You guys finish interrupting me? No, not done. Okay. Okay. Okay.
And his name is John C.
Okay.
Unfortunately, guys.
No, not unfortunately. Not
that
yet.
is gonna be it for
Jeebosh. Fuck. It is sad. Fuck! You're done? Uh-huh. Rude. That's what you are.
Your demise.
Yeah? Yeah? You lied? Yeah, you just wanted to wait for that one, especially when I die, huh? Fucking rude. Okay, as you were saying. Yeah. I'm not gonna lie, I have forgotten what I was talking about. What was I talking about? Before Jim interrupted? Yeah, thank you for telling me that. I do not remember what it was that I was talking about. Fuck. I need the Vine boom effect. Sure, send it my way and I'll add it. Which reminds me, I forgot to do the one Liffy sent me. No? Well then, wah, wah. Madge, yeah. They'll ever sleep so deep when you wake up, it's like your body forgot to breathe. Tom's here to take over. Bye! Alright. Hi, Tom! How you doing, buddy? I hope you're doing well. We were gonna add... Yeah, that's right. Yeah, your EP. You can't stay because work in Detroit is too hectic. No worries, bud. But I'm EP, so you have to. Yeah, the Perry emote, huh? Or, and hear me out, we both leave. Oh! No! The two trees! But Josh can't beat this guy without someone yapping, apparently. And if he doesn't beat him... You're gonna go crazy? Then we won't get to play Dress to Impress with our baddies. Is that literally the entire name? Or are you just adding the with our baddies? Ugh. You are adding it? Okay. So, this Dress to Impress stuff, Josh can't beat this guy, someone yapping is just a bonus. Yeah, Tom? So are you just saying that you want to play this because of all the, like, Roblox skins you've got? Or do they give you, like, other Roblox skins to use, by the way, Paige? Josh forgetting what he was going to say as per usual. I've never forgotten anything. What do you mean? Oh, I was so close. Oh, you don't use your normal avatar? Fuck. Game has a bunch of clothes and options for you. Okay. And how do you choose who wins? Does chat vote on it? Like, explain. Fight Club. Oh, now that's more like it. Now you're getting me. When the runway portion starts, everyone has a button to rate the fit 1 to 5 stars. Oh. Hello! Yeah. Yay. Hi.
Paige! Hello!
Yeah, Paige is in here. She's been inspired and decided to make a animated version of the EP emote. Yeah. Kate Hemlow. Yeah. You'll send a clip? Okay. When the runway portion starts, everyone has a button to rate the fit 1 out of 5. Ah, okay. So we all have to rate it 1 out of 5? Man, that's pretty rough. How does anybody win? You win by not ever giving someone else 5. Damn! Paige already in the meta. Yay! Thank you. This is really good, chat. No! 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 Fuck! Oh, I was so fucking close! Ah! Definitely down.
your demise.
It's not fair. Not fair. I was so close. Yeah. It's the AoE move that messed me up. If I'd been able to kick its butt or not go for that swing, yeah. If I didn't go for the swing, I would have had it. I did the hard part, and then I couldn't... Oh my god! No! Life is hard. Give me a minute, chat. Okay. I am back. That's Kai, but that's how the gameplay goes? Okay. There we go. Pardon? Good. It's been too bloody hot recently.
Bro, this is goth. Okay, let's see. It's not goth enough. It's giving thotty. It's giving thotty. It's do too. It's giving thotty. Now that's goth. Fire. 4. You get a 4. You get a 4. You get a 4. They don't understand you. I know. I know. Wow. This is giving like goth, but like, you feel me? Wow. I'm gonna give it a 3. I'm gonna give it a 3. I'm gonna give it a 3. It could have been more gother. It could have been more gother. Cardi! What is actually 5? Okay, yeah. No, no, no! White boots. Wow. Big slay. Slay, bitch. 5. Now that is God.
He's yelling so fucking much. Holy shit.
In GTA. Wow.
The game is unironically addicting, not gonna lie. And this man says his content is for grown adults. Bro, he's literally playing Bloodborne at the moment. Jim, chill.
What? Okay, I like this.
You don't like Kai, but his was the first to pop up. It's I think he's okay. I like him. I know a few of you guys don't like him at all. Yeah, I know Kate really dislikes him.
You match it with the ice cream. I like it. I'm gonna give it a 4. The white is what knocks it down to a 4.
But then again, I like Asmongold, and most of you guys don't either.
I'm gonna give it a 4. I'm gonna give it a 4. It ain't a 5. I'm gonna give it a 4 though. This is tough. I fuck with this.
Almond is crusty. Completely fair. I do not disagree. Yes. What grown person would tune into this? His screaming? I mean, apparently me.
Pretty God. How do y'all feel about this? I'm gonna give it a 3. I fuck with it, but I'm gonna give it a 3. I'm gonna give it a 3.
Yeah. That wasn't autocorrect. Asmongold is just lazy. The dude reacts to Penguin 0. That should say enough. People react to literally everything, Jim. Everything. React channels that react to other React channels confuse me. Hey, look, they get views. I understand, like, and it's, yeah, they get views, man. And if you really want to complain about it, complain about the people that watch it. Just say moist like the rest of us? Wait, what are you talking about? Oh, you mean Jim? No, Jim has to be very specific about Charlie. Yes, but Josh, moist. Charlie is a commentary channel with near zero editing. The Dredge of Society. What is there to react to? Hey man, I've never seen him this mad. The moist critical situation is crazy. Shut the fuck up. Hey man, he did the meme. I just wish he wore the the glasses with the nose. I wish he did that. To be fair, he could have done it in the rest of the video, but I saw that it was like 24 minutes long, and me and Kate stopped watching at around like the 6 to 10 minute mark because we were tired. And then we never picked it back up. Which is completely understandable because I think we were both over it by that point. It's like, I mean, like, we get it. That's enough now. Okay. Yeah? Yeah, sounds about right. That fucking reaction is more than double the length of the OG video. Bro. People watch it. Like, if it didn't work, he wouldn't upload it. Yeah. You don't even know what's going on. There's so much drama this month that hurts my brain. Yeah, that makes sense. There has been a lot. Asmongold is the male, less insane sniper wolf. Oh, yeah? You know! It's easy content! Is it? Well, I mean, if it's that easy, you do it too, Jim. Pop off. Too many people wanting to touch kids nowadays? No way. Hey man, it doesn't look like Dr. Disrespect is gonna go away. It looks like he's probably gonna come back. And he's probably gonna get quite a number of views on his comeback, like, stream. Reaction channels are bottom of the barrel. Not counting Lanky Bok. Lanky Bok. Lanky Box. Fuck! Yeah, Jim? Is that right? What's the difference between Lanky Box, or Lanky Bok, as you so familiarly called him? What's the difference? Also, what about, like, Jay Schlatt? Because he does reacts too. And I know you like Schlatt. Yeah, out of the loop. Internet drama, I don't give a fuck. Just stop caring because I feel fine. Completely justifiable, bro. There's a few, like, YouTube channels that have been, like... Well, the YouTubers have been caught, like, either messaging minors or, worse. And a lot of it's come out recently. And it doesn't seem to be just allegations. Damn. Well, that didn't work. Okay with people posting occasional React stuff as long as they post other content too, like Ludwig. I tend to avoid React-only channels. Fair. That's fair, I guess. Ludwig provides at least something of value in his discussions. Yeah. I mean, he did say recently about the Mobile Mail channel that he's not a big fan of it. And that he's going to try and change it up a bit more than what it has become, rather than what he initially intended it to be, which is funny. Most React streamers like Hassan and XQC are literal nothing burgers. I mean... yeah. You gotta walk away from your chair while you're playing, Hell's Kitchen and all of that, my friend, and, you know, without pausing. It's important, man. You need to make some money. You need to do it. Fuck. Ugh. They are top streamers, Josh. They already won the game. Can they please retire? No, that's not how it works. That never works that way, Jim. You want to stay at the top the whole time. Once you're at the top, you want to see how long you can stay at the top. And you also want to beat all the other people that are at the top. Also, Hassan is probably, like, staying there for quite a while due to, you know, the political things at the moment. Like, I highly doubt he's gonna drop much more. He's pretty good because of the political season. At least, you know, until the end of the political season. Then we'll see. You know? Yeah. Also, he's pretty to look at, so, you know, people stan him a lot. More than his ideas of things. But it's, like, also easy to criticize from, like, you know, this point. Where I'm not, like, at a huge point, like, viewer-wise. And I don't face the same amount of criticism, I suppose. I would like to think it wouldn't change me much, but I wouldn't know until I got there. That's why next weekend in the IRL stream. Be there or be square. I don't even know if I'm gonna do one yet. It's easy to punch up. Clearly, there has to be other ways of maintaining an audience, though. Please do an IRL. The children yearn. Maybe, but maybe. I might do, like... I don't know. Times Square parries. Okay, look. I'm definitely not in Times Square. I could always be not next weekend, but we got plans for something else. And I'm probably not gonna be doing that streaming. I'll probably do like, I don't know, like a walk like how we did up the mountain the other time. Or some cooking streams. Not sure yet. Should have waited longer. Pie stream win. Actually, I will do one of those, Tom. It's just currently I'm not there yet. I need far more practice. I haven't put enough skill points into it yet, so I need some more time. Need to grind it out. You don't know, this whole Canada thing could just be a figment of my imagination for all I know. Yeah, true. I could have just, like, pulled Kate over to New Zealand and just been, like, gaslighting you all on thinking I'm a lot closer than I really am. Believe me, if I were able to do that, I would have moved out of America ages ago. Well, I mean, you can still do the, what is it, work holiday visa, bud. You can do that, till quite a decent age. I'm not sure what the limit is for the States, though. I think you can only go for a year. Canadians get 2 years, and if you're, like, in England or one of the other, well, the UK, one of the other, you know, countries that are, like, Union Jack related, you know, Commonwealth related, I think you get 3. Just depends. That requires employment? No, it doesn't. You're wrong. Work holiday visa means you can be on holiday and then find work over there. You don't have to find work for the entire time. A lot of people will do that and find like seasonal work. That's what people do, bud. Since you're a citizen of the States, you can stay in Canada specifically without a visa for around 100 days. Yeah? But if you're meaning Canada, I'm not sure how that works for you guys. I assume, like, work for you guys to get over here would be, like, way easier than trying to get it in New Zealand. Well, what the fuck are you waiting for? Get you a goddamn net, catch some fish, start a campfire, and grind that cooking XP out by grilling it. I know you have a net. You get one on character creation for the tutorial. Oh, true. True. I gotta put some time in it. This is true, Tom. This is true. I got a message from Orc the other day, by the way, chat. While he was in England. He messaged me the pie mash and liquor that he's always on about. Back. 6, my phone died. Yeah. Not the number 6. No! Or how the Australians say it. 6. Soz. Yeah. Soz, you are forgiven. Or as the Kiwis say, Seeks. Yeah, we say Seeks. Do we? Seeks. I don't know, I say 6. No, I don't think I'm the same. What is pie mash and liquor and how can I try it? They have like a basic mince pie, Tom. Like beef mince pie. And the sauce, which is like the liquor part, is like parsley sauce. Which I didn't know that's what it was until I got a message from Orc because he got his mum to send an audio message explaining what it is. And they've also got mashed potatoes with it. Which is not on top of the pie. The pie has a lid. Okay? Like a pastry lid. Covering it. But they've got mashed potato next to it. Always got to be quirky and different. Maybe I'm just weird. Honestly, I bet it's probably from watching too much TV as a child. That's probably what it was, because I get a lot of American and British shows in New Zealand. So, you know, mixed my accent in with, like, some weirder shit. Which is probably why my accent is a little bit more neutral than Bro PP's. Parsley? You assumed it'd be mint? You're in? Definitely sounds good. I would definitely try it, don't get me wrong. I just think they're missing out. Steak and cheese pie is better. Also, like, it makes the pie itself soggy, apparently. Which I am not for. Because it's a very wet, like, almost watery sauce. You don't like soggy pie? Me either, my friend. Now, if it was in its own, like, little, like, cup thing and it didn't have nearly as much as it seems to have, because it covers the entire thing, it could be, you know, quite nice. But it seems like a little much. Even with our fruit pies, you dislike soggy crust. I'm not a big fan of soggy crust either. So you can see why I've been, like, yelling at Orc that he's doing a pie wrong, right? You can see why. Did I not? Maybe I didn't spam it enough. That seemed weird. Oh well. I am getting a little bit more consistent with it, though. Because I've dodged it the other times that it's come up. That move. I'm having more trouble with the falling meteor thing than I am with that currently. British people are the clowns of the modern. No, 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 no. They've just had, you know, a rough go of it with food because they, you know, they went through their beaches and they ruined them all. They like scrubbed the sea clean around them, pretty much. If I'm fair, I'd still try it because that's the way I was raised, but good chance I'd just end up shitting on British food by the end of it. I would be like shitting on that one particular dish. Now the other things, maybe it'd be a bit better. Toad in the hole, beans on toast. Look, beans on toast is actually great. We eat that in New Zealand, alright? It's not that bad. Baked beans is great. No, Tom agrees. World War II, British people had it rough. Oh, yeah. 100% I agree with you there. Made do with what they could. Never going to New Zealand now? Yeah? Didn't think I had enough time. Y'all can keep your pies? Yeah. We do make the best pies, Jim. Meat pies, at least. Fruit pies, we don't really do. We probably do a better custard pie than we do, like, any kind of fruit pie. I think we might do pineapple pie as well. I'm not actually sure. I know we've got a couple places that do, like, apple pie. And then, like, rhubarb and that. Like, again, it's not that common. It's the steak and cheese and mince and cheese pies, like the meat ones, that really get you. Lamba pies are pretty good too. But not everywhere has those. That's far less common. Probably less common than the butter curry pie. Butter chicken pie, sorry. And I miss butter chicken now. I haven't had that in forever. If Bro PP was in chat, he'd be typing in, "You're so basic!" You're gonna be a foreign diplomat? I'm gonna be a foreign diplomat and advocate to the nations. Also, Jim, in any other country, yes. Could I get chicken tendies because my delicate palate can't try anything new because I'm a child? Me and Tom at the same time, though. You know what? I'm gonna go to England, try their food, and complain about it. Who the fuck said that? Who said what, Jim? The chat won't refresh? You did, bitch! Yeah? Point him out. It was Tom. I mean, you can see up there who wrote it. My stream's in 160p, and either way, I ain't reading all that. Happy for you, though. Yeah? This is right. Well, sorry that happened. Yeah? I did say Jamalthi. I could have parried that, bugger. You're not gonna be like that? Oh. Yeah? You're not gonna advocate to the world? You're just gonna be like, fuck you all? Rude, Jim. Rude. Did y'all forget I was literally just in France a month ago? Yeah? Did you try the froggy's legs? Did you try the schnoss? Fuck! No, those weren't on the menu. Ugh. I don't know, Jim. I don't know. I didn't promise to shit on Britain's food, but watery crust isn't considered culinary gold. I'll agree with you. Bro, frog legs are good as fuck. I haven't tried them. The idea is... Yeah, I don't know if I could try them. Okay? The idea of frog's legs actually gets in my brain. It's like the idea of trying bugs, which I know like in some places you could. I could try a hoo-hoo grub. Okay, that's from New Zealand. I know that sounds weird, but like me trying other bugs, I don't think I could stomach it. Like a scorpion or something. Too much in my own head. I know that doesn't make a lot of sense, since I could try a bug from New Zealand and I couldn't try a bug from somewhere else. Pure protein. Damn, NZ has Neanderthal food. Love the foods. I've never tried one, alright? And you can go out to the bush and get it. It's not like you could go to the store and easily get something. There might be a place where you could go. Right, Jim? To find it? Entirely possible. I wouldn't know where. If there is. I'd have to Google it, I guess. Bugger me! Ah! You view them like chicken wings, good, but I won't order them because I need too many to feel satiated. I mean, frog's legs are pretty small. You'll need a lot of frog's legs to feel well fed. Yes. Oh, I don't doubt it. It's just the idea of, like, eating a frog seems gross to me. They could be great, okay? Unfortunately, my brain wouldn't let me. Like, even if I tried them, and thought they were great, didn't know what they were, and then got told later, I might throw up. I'm not normally that squeamish with shit, right? But apparently I am with that. Snails, I think I'd have less of a problem. I could probably try that, but, like, it still seems a little bit gross. Snails are what fuck with you? You couldn't try escargot? Damn. What about escar stay? What if the car just doesn't move? I don't know if I could try horse. It apparently runs right through you, which is funny. Apparently it goes right through you. Car don't do that. Car meant go. Oh. I don't know if I could eat dog either. I don't think I could. I could eat rabbit. Rabbit's not a problem. Horse sounds really good. Yeah. Does it? Have you tried Lambert, Jim? I'm pretty sure Lambert isn't common in the States, right? So far, I'd say the only thing that has gotten to my head was eating cooked pig skin at a food truck in NM. It was delicious as fuck, but my initial hunger died down. I ended up not finishing the last 10% of the meal. Didn't vomit, but did get close. What do you mean by, like, pig skin, Tom? Do you mean like crackling? Or is this something else? Sprinkle some salt on it? You're laughing? I have to Google this now. Yeah, that's crackling. No, boiled. Oh, boiled? Okay, yeah, that'd be different. Much rather have it as like crackling rather than like boiled. I can see. I think I've had this before. I think I've had this before. This seems better. Because it seems like it's glazed. But this is just straight up boiled, I think. This doesn't look half bad. But I much prefer it like this. Or like this. It was like Jell-O, not fried. More like this? That's not how you spell boiled. So more like this one, right? I forget where I've had this. I think I've had it before. I think it was like okay, but I'm not like in general a big fan of pork. Yeah? Yeah, I would not go for this if I had a choice. It's so tasty. Was it actually? Was it like having too much of it is what sent you over or what? Because sometimes having too much of something can do that to you too. Especially if your tummy's not used to it. Bro, PP loves getting crackling from the roast shop down the road. Too soon, I guess. Wah, wah. Man, I'm getting hungry now. Because this just see is a bit much, but with the idea that this was what human skin would taste like, well, I believe I'd be the cannibal in an emergency situation. I love pork, and it said that human isn't far off. Yeah, I've heard that, and the smell. When they train trauma responders, they burn pig flesh and things so like they can get used to it. Because obviously we've evolved to have like an aversion to that sort of shit. You sweet man, I'd be bringing some barbecue sauce and baked toast. I think it's a specific way that they do it to make it smell more like human flesh too, bud. But those were my initial thoughts too. That if you just like pork, it wouldn't be that much of a problem. But back when my mom told me this when I was a kid, I was like, man, that would be terrible. Because I hated it. Missed the last 2 minutes, the radio mutes when I'm backing up. You're fine, bro. Honestly, haven't said a lot. I'm eating chips. Gang isn't on VC, how rude of us. It's okay, you guys don't have to turn up every day. No, every minute, every hour of every day. Yeah. The rest of them are all slackers. Oh. Give me a minute, chat.
And we say bye-bye.
Okay, I am back. Hello. In my RimWorld colony right now, I have a cannibal pawn, and I really want him to get that forbidden long pork just to see how happy he gets. Yeah. How do we feel about my little thing, by the way? I've been like my controller at the bottom, by the way. That's what I meant. Should I like? I've been wondering if I should make it a bit darker, like that, or that. Ugh. Oh yeah, where? That's fun. Go. Ah, Lynn. I think I should have like rolled one more time. I think I waited too long for the next roll. Wah, wah. Da, 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 da. Ay, 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 ay. I should have known better. I haven't done that mistake in a while. It's okay. We'll get there. I could have done the quicker one. Burger. Oh well. Burger. Funny. I think if I'd pushed jump and or the if he attacked a little bit quicker, I might have gotten him sooner. And he might not have been able to get the attack out. I thought I pushed that button. Bugger. Okay. That really didn't let. Not good. Not good. Very bad. I guess I should have known better. Hydrate again, huh? There you go, my friend. Chug, 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 chug. Mm-hmm, 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 mm-hmm. I don't think I did enough to the side. I was so close. That wasn't hitless. It's getting there, though, right, Panda? How has your day been, buddy? A bit of be trying to watch you to learn how to play these games. Which one are you planning to play, my friend? I knew not to do it, and I did it anyway. Middle pipe plank. Pretty good. Trying to find a few dollars for a game bundle you want. Oh, yeah? What's the game bundle, my friend? Let me hear it. Already own Hollow Knight, so I'd probably start with that. But in terms of Soulsborne's DS1, oh, I'm bad. 19 Lego games for 15 bucks on the Humble Bundle. Oh, damn. Can pay more to donate to charity, but I'd be broke. Hell yeah. How have the streams been anyway, bud? Have you started Hollow Knight yet? Also, like the Dark Souls games especially are good to get on when they're on sale because there's like a resurgence of people that play them too. So like if you get like during like the winter sales or something, or the summer sales, autumn sales are probably the next one. I last played March 14th, 2021. Oh, well, then you got to start a new playthrough, bud. Hell yeah. People love that. Oh, no! I got it, too. I fucking got it, too! Oh! It was the last little, like, it was my foot being over the line on that part. Because I was trying to dodge roll the big AoE, and I forgot about not being close enough for the line one. You don't stream anymore, but you're excited to play nonetheless? Oh, hell yeah, bro. Hollow Knight is a really, really fun game, bro. I can't wait for Silk Song to come out. That I am surprised that missed. It is, well, I found it terrible to navigate in the first Dark Souls 1, even though, like, it's really well put together and everything. If you do need a hand with it, feel free to drop by the chat when you give it a go, okay, Panda? And ask questions. Or, like, yeah, it's... It can be rough. Slacker. Name one slack, Jim. I have never slacked ever. That I could have rolled, I guess. Hello. Hey, Johnny. How you doing, my friend? Yes. Well, I'm getting the one that I had like so much difficulty with down, but now there are more problems. I say more problems. It's not really more problems. It's the same other problem I had that I haven't quite fixed yet. You doing good? Oh, damn. BR Sinister. Putting links in chat to try and get us to buy some awesome, amazing, good viewers, huh? Best viewers. Good viewers. Cheap viewers. There you go. Hang on. That is a good question. What does define best viewers? Tell me, chat. What is best viewers? Yeah, what does best viewers mean to you? Viewers that give me all their money? JK. Tipsel viewers? You hate Asmongold? Damn. Man, my whole chat hates him. I like him. Is this where you exit stage left, Johnny? Is this the last time I ever see you? I can understand why he's not some people's cup of tea. But I like him. No. Because I don't care if you like him. Hell yeah. Woohoo! I'm not cancelled by association! 10 words of wisdom, viewers? I don't know if you're trolling me or not. He's stupid and disgusting. I understand the non-cleanliness deal. For sure. You do not have an argument with me with cleanliness with him. Dude had gum blood on his walls for months. Gum blood. He had a problem with his gums for a while. Too much soda. The hottest competition of anthropomorphized books on YouTube. Oh, okay. Well, I'll have to believe you, Jim. He has viewers pay him to clean his room. If he starts to clean up his act, though, Johnny, you think that his viewers would start, like, to stop watching him? Also, I don't think he cares that much about, like, cleaning his room. And I don't know about the cleaning viewers thing. I don't actually watch his stream, so I don't know how true that is. But he's literally, like, at the very least, I know it's not people paying subs. If it's donos, then I'm not sure. He had bloody gums. He would toss it on his wall. It's where the Tawau and Jim Tawau comes from. Oh. Gumblood? What? He has, or had, really bad gums. And teeth. Too much soda. A lot. He's a big Dr. Pepper fan, and, you know, coupled with the fact that I don't think he probably brushes his teeth. Well, he didn't used to. It might have changed now. Oh, that is disgusting. How the... Jim, you do not want to go down the rabbit hole of, like, how disgusting some of Asmongold's habits are, okay? Like, I'm not gonna fight anybody on the cleanliness of his place or his habits, okay? He knows it too. He is complete gremlin mode. I get that. You're not getting an argument from me. That's what World of Warcraft does to people. Dude, I've inflamed gums right now. How the fuck does that shit get on your walls? Probably grab the blood and just flick it like that. Rather than have it, like, in your mouth. Or he spat it on the wall, yeah, which, yep. Both cases, yuck. Trust me, Jim, you do not want to go down that rabbit hole of, like, how bad can it be? Because you will regret. But I find his content entertaining in general. Apart from when the disgusting habits pop up in videos and then I'm like, man, I don't want to hear this. Yeah, Shady? You're gonna fucking throw up? Holy shit. Yeah, Jim, again, I told you, you don't want to know. It is good to see you, Shade. How do you feel about the little controller I got down there? I'm, like, pointing in the wrong direction because it's hard. It's that way. I had it more clear, but well, I had it, like, not more clear. I had, like, it more see-through, but I felt like it was hard to see during this fight because everything's so bright. So I darkened it up a little bit. I can always turn it back if you guys think I should have it see-through again. He steals views from people react. That's debatable. People that like to watch reacts don't necessarily watch those videos in the first place. If that makes sense. Like, it's a bit of a debate. Like... Yeah. I can understand a bit how you feel about that. But most of the time, people don't get to see those videos anyway. Those people that do reacts, they would probably just watch somebody else react. Hold on. Who are we talking about? Asmongold. Chat's not a big fan of him, and I am. You can't claim he's helping these people when we're sometimes... It depends. It depends. Like, these people like watching Asmongold. They don't like necessarily watching, like, these other people's things, and they like hearing his takes and stuff. I'm not, like... Yeah, like it's like a give and take type thing for sure. It's obviously a lot better when he like does. Also, in his Twitch chat, he does generally do shoutouts of every single video that he watches. I'm not as sure if he posts the original video in his YouTube. You have to make an announcement in Jim's Poncho Pavlova. Hey, what? You like him? He usually has solid takes. Usually with streamers giving reactions is that they barely say anything. They just stare at the screen and nod once or twice. Look at XQC, for example. He once reacted to a video only saying one word. Look, you're not gonna like get necessarily a disagreement from me with some people's reacts. And Asmongold just says, "Wow, that's crazy." Chat once or twice. Sometimes it depends on like how much he knows about the subject. Like there are like a few videos like Jim mentioned before, like where he'll like have the video twice as long as the original, just talking off on shit. Now, if you really want to get off on people, it would be like someone that plays a video and then gets up and walks away from it while it's still playing. That I can understand. Like some people on YouTube don't care about the reactors, and some people do. Like it can help some people, and I suppose it can like mess some people up. My opinion is probably don't, if you're going to react to a video, try to stay away from it for the first few days, because that's when it gains the most traction in the algorithm. At least that's what it seems to be, right? Don't try not to react within the first few hours and like kind of let it go its own way for a bit. Maybe like a week old or something. I don't really have a hard fast rule for it. Just definitely leave it alone probably for the first at least 3 days. But when
I ain't fucking around anymore, Josh. Watch Bluey. Watch it now.
When he misses his own goals. I have missed said context to that, Mr. Jim. Oh, when he misses his own goals. Okay, yeah, now I get it. I hate big streams reacting to content and pretending they are somehow helping. Anyway, no more Asmongold run. I could keep going. That's okay. Like, we all have, like, that one, like, subject where we're like, I will keep going and going and going because I hate it. Mine is Kingdom Hearts 3. I once paused a game just to rant at chat for, like, half an hour. Like, this is in Kingdom Hearts 3 when I had to replay it. Like, about how bad the game was. I would do it, like, all the time while I'm playing it. I just pause and be like, this game is so bad. Yeah, yeah. Yay. How much do I have to pay you to long play it? What's a long play? Explain. Random ghost kisses on the on the head. Hell yeah. The spirits love me, chat. Ugh. Okay, he's not doing the thing. one after the other? Lame. Beat the game in one sitting? Not like a speed run though? I don't know if I could beat it in one sitting. Like, does that mean like... would that mean, kind of like a subathon, I guess? And what counts as beating it? Because there's some, like, arena-type things that they included as well, and I want to know if that would also count. That move where he slices down from above is kind of bullshit. I have been getting better at it, though. More consistent. That one I just died to. Like, he always does that particular one after the meteors. I've, like, dodged it 3 times successfully today. Maybe a little bit more than that. Whenever it's come up, and it's only come up, like, a few times. Just the main campaign, not 100%. Okay. Fuck. Does the difficulty matter? And, like, what? I can't end the stream until, like... I beat the game? Because the game takes a minute. It's not like a necessarily short game. No? So what, it would just span multiple streams in? I'm so sad that didn't parry. Oh, I thought for sure that would be early enough. All the long plays on YouTube are 22 hours. So it has to be one sitting? Like, I can never leave? Yeah, so, like... That's a rough go of it, Jim. 22 hours, man. I'd have to, like, super prepare for that. I don't know, like 100 subs? If it's gonna be 22 hours and I have to sit, bro, and I probably don't beat it in 22, it's probably gonna be at least 24. That game holds a special place in hell, chat. I accidentally jumped! I had that! Fuck! What guy? Alright, Jim, you might have to jump in the VZ to explain. I don't know what you mean by what guy. You said someone had a special place in hell? No, not the guy, the game. Kingdom Hearts 3. Bad game. Bad game. Ooh. Hello? Hello? Give me a minute, chat. Okay. Unfortunately, no. Though, chat. Look. Oh, ooh. $60. Fuck no, I'm not gifting that. Gifting what? Oh, you mean the game? They did put it on Steam more recently. Yeah, I saw that. KH3, yeah. I really enjoy the previous games. Of the ones that I've played. I've played like 1 and 2, and then like I forget what the other one's called. But like I haven't played a lot of the other in-betweeners. I hugely dislike 3. So we are gonna raid somewhere. Let me see. Yeah, exactly, Shady. See you later. Yeah, bud. We are gonna raid Chris, alright, chat? If you could give him some love, I would really appreciate it. He's a good lad. I had to move over here because Ad was playing. Come to find out you're leaving, so rip. Yeah, I know, Johnny, I know. My bad. Um, hungry though, bud. And so I gotta head off for the night. But I will be back tomorrow. Itchy chin, man. J boss. Kick butts. Tech names. Yeah. Nearly full gore. I would never. Jopus. We good. Bye guys. Yeah.